So today I wanted to show you the working of a half wave rectifier and a full wave rectifier. Right? So here I have a transformer, so it's converting the 220 volts into 20 volts. And here I have a resistor, so the light lamp is nothing but a resistor. And you can see that the AC circuit, the AC waveform is something like this, from this, right? But what happens if I connect it like a half wave rectification? So I have a PN junction diode here. So when I put this PN junction diode, you can see that half of the waves are going away. So why is this happening? This is because if you come over here, so this is the circuit for half wave rectifier which we have over here. So that means one moment this is plus, and this is minus, which means this is in forward bias, which means this half wave is kind of coming through the resistor. But the next moment this will become plus and this will become minus. When the plus goes over here, it is in reverse bias. So since it is in reverse bias, this part, right? So it cannot, the current cannot pass through this. So that means this half is kind of cut off. The same thing is repeating, and this is what we call as half wave rectifier. And that's what you are seeing here in the AC waveform. So you can see half the things are missing. But suppose if I come over here, right? So in full wave rectification, of course, we are not satisfied with this, right? We don't want to lose this half of the energy. So that means we want to get this also. How is this achieved? So this is called full wave waveform. How is this achieved? By using two different diodes. So one moment this is plus, this is minus, which means the current is flowing through this, right? Like this. Why? Because this part, when this is plus, this is minus, which means the current is flowing this way. The next moment, right, since it is alternating current, this is plus and this is minus, which means this is forward bias and the current is flowing this way. Which means if you see the resistor, right, it doesn't matter whether it's coming, the current is coming from this diode or this diode. The current in the resistor is always in the same direction. Which means what happens is, the one which was going down, it's the opposite polarity, is also shifted over here. And this is what is called full wave rectifier. So let me show you how it works here. So you see I have another PN junction diode connected over here, right? So when this is connected over here, you can see that the waveform is, the full wave is coming through, right? So either earlier the half of which was lost. And look at the brightness of the lamp. So if I remove this, you see the brightness is reduced because only half the energy is going through. Now the moment I connect this, since it is full wave going through it, because of that you can see that the lamp is glowing brighter. And this is what is called full wave. And if you ask me, are we satisfied with this? Again, we call this as ripples. So we are not satisfied with this, right? So this is called ripples. So this going down and up and down waveform, we are not satisfied with this. So what we do is, we put a capacitor in parallel. When you put a capacitor in parallel, as you know, capacitor stores energy and gives it back, right, when it's required. So that means when something is going like this, what will happen is, the moment I put this capacitor, it will store the energy. When it is going up, it will store the energy, and when it is coming down, it will give back the energy. And this we call it as smoothing by capacitor or smoothing by capacitor. So that means we are kind of trying to reach the DC voltage. So the DC voltage is something like this. So let me show you what happens when I put a capacitor over here. So when I put a capacitor over here, you can see the ripples is gone, it's gone, and then you can see it's almost like a straight line. And that is what we really want for a DC current, right? And that is why the rectifier, the name rectifier means you are converting the AC into DC. And as the capacitor value increases, this ripples up and down motion, right, it's kind of reduced. So all I am doing is I'm taking a capacitor and I'm putting it over in parallel to this as shown in the circuit. Okay.